Hi, my name is Mahmoud Yaman Sirajdi, and today I'll be presenting assignment 3 for the advanced machine learning course. So let's get started. This block installs the required libraries. I added scikit-learn because Azure was acting weird. It wasn't detecting scikit, so I added it, installed it, everything works fine. I did not run these cells. I'm not using Google Drive. Um, Imported the libraries, created a seed, and then I loaded the data, the given data. And as we can see from the first 5 items, we have a label column and then 784 pixels, which represent black and white images, a 28 by 28 black and white images. So here I'm splitting the data, and as you can see we have 56,000 examples, and then I'm describing the data set. I plotted a bunch of examples, so we can see we have a dress, we have a handbag, we have a sweater, and we can see how basically the data, how the data is given. Because so these are not just random image or like any image of a bag, it's the silhouette of a bag. Okay, so the goal of the model is to learn to distinguish a bag from like the following example. Okay, so here I'm splitting the data, the same function I've used in the previous assignments. Then I'm normalizing the data and transforming it into basically um, a training is validation and test splits. So I'm normalizing all three. Okay, and then I'm creating a simple CNN that has a convolution, a max pooling, and convolution, another max pooling. Then and we have a fully connected layers and a dropout layer, and finally a softmax output. Okay, so here I'm basically, so it's the same as the last assignment. I'm converting the string labels into integers, so the model can work with them. Then I'm training the model using the training data and the validation set. And here we have this function which plots the curve. Train the model using 20 epochs, and as you can see we have the graphs here. So basically these graphs show that the model is overfit because the validation is way higher than the training error. So and same thing with the accuracy. Okay, and then we create another function which introduces regularization. Okay, L2 regularization, and we keep the dropout. Okay, so we train the model using the same batch size, same epochs. Okay, and we get this, which is perfect. So the model is neither overfit nor underfit. Okay, it's perfectly fine. So now we go to the hyperparameter tuning. So for the values I just used the examples. I didn't go all in basically in order to save time on the computation. I believe this took some 2 hours if I'm not mistaken. Like I just left it to for 2 hours and then came back and it finished. I obviously saved the model using Keras just in case, because you don't have to train it every time. And then we evaluated on the testing. So we have an F1 accuracy of an F1 macro of 91%, and then testing accuracy of 93%. And then I evaluated the model on the test dataset, and as we can see, the model works flawlessly. Okay. Then we have the second exercise, which is basically we're given 32 by 32 images that are black and white, and we have to change them into we basically have to color them. Okay, so we're given black and white images as the colored variant of the image to train the model, and we have to basically figure it out. So I just ran the code that was provided. Okay, nothing special. Okay, let's go back down to the figures. Okay, so this is the model that was provided, or the architecture that was provided. The data was downloaded, colors were added, etc. And then where is it? Train the model. Okay, it had a 44.1% accuracy, and it took somewhere around 3 minutes. No, it's more than 3 minutes. Yeah, 3 minutes. Okay, and this is the output. So basically we have the input to the model, we have the output, and then we have the output of the result. So basically this is what our model gives us. As you can see, the images that are given are blurry and they don't have the same so basically they lost a lot of the features, a lot of the details of the input images, and they are not colored. They don't have proper coloring. So basically none of the examples is colored properly. Maybe like this one, maybe, but yeah, the model did not perform well, and this is mainly due to the max pooling in the image, and not in the image, in the architecture. Okay, so there are a couple of 2D max pooling layers, and these are probably what causing the image to lose a lot of the data and become blurry. Okay, and also we're not using any skip connections. So even so, if we use the skip connections, this could have been mitigated. I'm not sure, I didn't test it out. Yeah, but the main issue is due to the max pooling layers, I believe. Okay, and yeah, basically max pooling and basically the encoded data. When the data is encoded in the model, it loses a lot of the information that were provided by the images, and thus the decoder cannot bring back the features, nor can it color properly. Okay, so this was the assignment. Thank you for watching, and bye.